Hello class, today we're going to cover section 11.4 and 11.5. 11.4 focuses on quadrilaterals and 11.5 focuses on polygons. We're talking about a quadrilateral. We're talking about a simple closed figure with 4 sides and 4 angles. Simple means that the sides do not cross over each other. Closed means that there are no gaps. So on the left here, you'll see a few examples of quadrilaterals. On the right, you will see examples of what are not quadrilaterals. When we are classifying quadrilateral, the basic shape is a quadrilateral. 4 sides, 4 angles. Then we have some specific categories that you can see as we break down here. Off to the left, this offshoot is called a trapezoid. This is something you've seen before. This means that a quadrilateral has exactly one set of parallel sides. So right now it's that top and bottom. It could be turned onto its side, and we could be looking at the left and the right, but either way there is one set of parallel sides. If you come back over to this right offshoot, the first option is a parallelogram. So we have both pairs of opposite sides are parallel, so top and bottom are parallel, left and right are parallel. And then we also have the opposite sides are congruent. So right and left are the same size, top and bottom are the same size. Our opposite angles, so top angle over here and bottom angle over here, are congruent. And then we have our 2 smaller angles are also congruent. Breaking off on this right side, we have a shape called a rhombus. So it has the same qualifications as a parallelogram. So we've got our parallel sides, 2 sets of parallel sides, but now all 4 sides are equal. So all 4 of the measurements are equal. If we come off to this left offshoot, again, same qualifications as a parallelogram, top and bottom parallel, left and right parallel, top and bottom equal, left and right equal, and now all of the angles are equal. So we've got 90-degree angles in all 4 corners. And then this bottom one, the most specific shape that we have is a square. All 4 of the sides are congruent, all 4 of the angles are congruent, top and bottom are parallel, left and right are parallel. So when you're naming a quadrilateral, you want to be as specific as possible. So if it is a square, you want to call it a square. If you can only call it a parallelogram, then we leave it up top. So this one on the left, we're looking at 2 parallel lines, and that is going to be a trapezoid. We only have the one set of parallel sides, left and right. If we are looking at this one on the right, we have no sets of parallel sides, so we would simply call this a quadrilateral. The next thing we want to note about quadrilaterals is that all of their angles add up to 360 degrees. So when you are finding missing angles, we can use addition to help us out. So this first angle is 90 degrees. So I've got 90 degrees plus 75 degrees. So currently, I have 165 degrees. I also have x plus 7 and x. So I'm going to add all of those up together and say 165 plus x plus 7 plus another x is equal to 360 degrees. I can simplify by combining like terms, which is going to give me 2x plus 172 degrees is equal to 360. Then I'm going to go through and use SADMEET to solve. Subtracting 172 from both sides is going to give me 2x is equal to 188. Then I'm going to need to divide on both sides by 2. So I get x is equal to 94. So that means our x value up here is 94. Then I'm going to have to solve x plus 7, which is going to give me 101. So our 2 missing angles are 94 degrees and 101 degrees. Other vocab that we have for this section is polygon. So that is a simple closed figure formed by 3 or more sides. Each of the sides intersect at their endpoint. That's what it means to be simple. So we don't have any sides that cross over each other and then meet. So we can't have anything crossing over. Closed, again, means that there's no gaps. A regular polygon means that all of the sides and all of the angles are congruent. So for example, an equilateral triangle, where we have all three sides the same measurement and all three angles of 60 degrees, would be an example of a regular polygon. First thing we're going to want to do is decide if they are polygons or not. So looking at shape A, this is going to be yes, because it is simple, nothing is overlapping, and closed. Looking at B, the answer is no, because it is curved. Notice it says in the definition 3 or more sides. A curve does not count as a side. Next, we've got C. Again, this is going to be yes, because it is simple and closed, no gaps and no overlaps. Same thing happens with D. Yes, it is simple and closed. And then for part E, the answer is no, again because of the curve. Another thing we're going to want to be able to do is to classify polygons. So we do this by the number of sides that they have. So our first one is a triangle, and that has 3 sides. Then we've got quadrilateral, which is what we talked about earlier in this lesson. And that has 4 sides. A pentagon has 5 sides. A hexagon has 6. Heptagon has 7. Octagon has 8. Nonagon has 9. Decagon has 10. I'm not sure why they skipped 11 when they were giving them names, but then we jump to 12 and we call it a dodecagon, and that has 12 sides. If it's anything more than 12, we simply refer to it as an n-gon, and that has n number of sides. So if I said a 22-gon, it would have 22 sides. So looking to classify our polygons, first looking at the first one, we would say not a polygon, and you would give a reason, and your reason for this one is curved. Yep, they already got it. Next, we've got a simple closed shape, so we're going to count the sides. 1, 2, 3, 4, 5, 6. So this is an example of a hexagon because it has 6 sides. Then we're going to go to the next one. 1, 2, 3, 4, 5, 6, 7 sides. So this is an example of a heptagon. Other things that we need to know about polygons is that we have interior angles. So these are the measurements on the inside of a polygon. So if I'm looking at a triangle, 1, 2, and 3 are my interior angles. Later when you get into geometry, you'll start talking about exterior angles, which would be 4, 5, and 6. So we're only concerned about the interior angles right now, those angles that those angles that are on the inside of the shape. One thing we need to note about interior angles is that for any particular polygon, the sum or the total of their interior angles is equal to the formula 180 n minus 2, where n is the number of sides of the polygon. So, the interior angles of a dodecagon, remember that is 12 sides. In order to do this, we're going to do 180 times 12 minus 2, which gives me 180 times 10, 180, which gives me an answer of 1,800. Same thing's going to happen if I have a 16 gon. We're going to plug that in for n. So 180 times 16 minus 2, which gives me 180 times 14 for a total of 2,520 degrees. So we're simply following the formula and plugging in our n values. You also can find the measure of each angle if it is a regular polygon. Again, that means all of the sides and angles are equal. Our formula for this is 180 times n minus 2, and then we're going to divide by n. So we're going to take the formula we just had and then divide it into n angles. So for example, with a pentagon, I would take 180 times 5 minus 2, and then be dividing by 5 because there are 5 sides. So 180 times 3 divided by 5, plugging into the calculator gives me 108 degrees per angle. Same thing would happen if we use a hexagon, but now instead of using a 5, we're going to plug in 6 for n. So we have 180 times 4 dividing by 6 is equal to 120. Both of these gave you whole numbers. Not all of them will. Just round to the nearest hundredth if you get a decimal. Now that you are done with the lesson, you can bring up your notes, show them to the sub, and receive your homework slip.